I'm going to walk you through a demonstration on how you can use historical data to quickly do large predictions on new data sets. In this instance, we're going to look at how a bank or similar institution can predict whether an individual makes more or less than $50,000. In fact, let's say that the bank wants to find people who make more than $50,000 and whom they have a high confidence make more than $50,000, perhaps to present with a special loan offer or something similar. So first, let's look at our historical data. I have two data sets here. These are the bank's current customers, and they have certain attributes on all these individuals. This is a standard CSV file. You'll see we have records on around 16,248 individuals, and we have certain attributes about these individuals as fields of data. So we have their age, their work class, education, marital status, occupation, relationship, race, gender, capital gains, losses, hours worked per week, their native country, and finally whether or not they make more or less than $50,000. So this is a type of data that they may have on hand already about pre-existing customers. So the first thing we have to do is log into our account with BigML. And this is our dashboard. All right, so now I'm going to simply bring this data into BigML by dragging it into the interface. We can also bring sources in through web links or through data sources that may be on Amazon S3 or other environments. So we now see the current customers CSV in our source list. So let's open up the source. Now the first thing you'll note here is that BigML has flipped the table on its side, so our fields now are rows, and then we have some instances here as columns. We'll also see that BigML has categorized the data into one of two types. In this case, for age, it's a numeric type of data. And for work class and the many others, we have categorical data, where it's this, that, or the other. Not shown here are two data types that BigML can handle, which are unstructured text and also time and date data as a data category. Now we can scan down the first 25 instances of our data and make sure that everything lines up okay. If anything's amiss, we can configure the source up here to handle headers differently, missing tokens differently. And in this dialog, we can also change the category or the data type of the data. So for example, if I wanted to treat age as categorical, I could do so. So this is our data source. Now the next key step that we want to take here is to create a data set. And I can do that here through this Configure Dataset button. So here's my data set. It's called Current Customers Dataset. If I want to change the name, I could. If I want to take a smaller section of the data, which I may do with a larger data set, I could do that here. So I'm going to create the data set, and here's the data set view. So in this view, you'll see that we now provide you a structured look at your data. We provide some top-level histograms. So for numeric data, you can mouse over to see the distribution, and on the right-hand side, we have a summary of your standard statistical measures. For categorical data, you can mouse over to see how the data splits out. In this case, for work class, we can see that 11,316 people are private workers. A couple other things you'll see here in this view are towards the bottom. So this crosshair here is our objective field. So this will be the objective for our predictive model. By default, we target the last field to be our objective field. You'll also see this exclamation point stating that this field will not be included in our model. So BigML has some heuristics on the back end that recommend fields that should not be included, perhaps based on the data distribution or other factors go into that recommendation. So in this dataset view, users get a good feel for their data and also decide which fields they want to include in their predictive model. So the next step is indeed to create a model, and here I go to the Configure Model option. And in this dialog here, I can choose the objective field. So if I want to choose anything other than income, I can do so here. I can also do a variety of advanced configurations. This controls the depth of my tree. I can handle weighting differently. I can handle sampling as far as the sampling rate or the type of sampling I wish to do. At each step of the workflow, there's a variety of more advanced options for more advanced users or for more advanced and complicated data sets. But in this case, I want to go ahead and I can also select or deselect fields to include in the model by simply checking or unchecking the field box here. In this case, I'm going to go ahead with BigML's recommendation to exclude native country and leave all the other fields in. I'm going to go ahead and create my model. So BigML uses decision trees as our core algorithm. Decision trees are very quick to build and they're easy to understand by technologists and business users alike. In addition, they can be easily combined to build ensembles of trees, which is a very powerful predictive methodology. But let's take a look at our tree. So this is based on our historical data. We have a decision tree, and at the top is what we call the root node. And the root node is the core field that helps split the data to come to a predictive conclusion. As we mouse over the root node, we see a summary of the data and a prediction on each step of the tree. So in this case here at the root node, we see that the prediction here is that someone's going to make less than $50,000, and we have a 75% confidence of that prediction. We can also mouse over how the data splits here to get more insight into that data. On the right-hand side, we see our prediction path, which names the different fields that are reflected in the tree. So in this case, marital status is the root node. As I work down the tree, I move to the left-hand side here. I can see that if someone is married or in a civil union, in this instance, the confidence goes down that they're going to make less than $50,000. And if I take this split here to the right-hand side, on capital gains, which is the next field, I could see that all of a sudden my prediction changes quite dramatically if the capital gains are over $5,094. In fact, based on this data, I now have 97% confidence that someone's going to make over $50,000. And again, if you look to the right-hand side on prediction path, you can see age is the next key field. Here we see that if someone's under 59, the confidence goes up. Education is the next field. We see if they don't have a preschool education, presumably meaning more than a preschool education, we now have 99% confidence that someone's going to make more than $50,000, and that is the final step, the final leaf in this branch. In fact, the final predictions are symbolized by a green leaf with a solid line around it. BigML uses information gain, so as soon as added information does not improve the prediction, we have the final prediction or the leaf node here. Now, individuals can work through the splits in the tree to look at how the data splits. So, for example, in education here, we see that if someone had a preschool education, we have very low confidence that they're going to make less than $50K. We compress the tree here to only show predictions and branches that have a decent level of support and confidence. We can also work through the tree here to sort by prediction, right? So if we only want to see predictions for people who make more than $50K, we can do so here. We can also dial up the confidence. So let's say our magic threshold is 75%. Here we see all the predictions for people who make more than $50K with over 75% confidence. And we can mouse through the tree here to see what the prediction path yields. We also have another view in BigML called the sunburst view. And the sunburst view gives you both the confidence view of your data and also a prediction. You can sort by predictions as well. So this center node here is the root node, and then each rung out represents a different branch in the tree. The size of the rungs reflect the size of the data. So in this case, let's say I want to find a very confident prediction. I could look for something very light green, as is the case here. In fact, this brings us to that same prediction we had earlier, where someone is married or in a civil union, has good capital gains, is under 59, and has more than a preschool education, and we have the same prediction of 99% confidence. So, this view in and of itself provides a fair amount of data and allows people to understand hidden relationships between different fields in their data. And in fact, someone, a bank worker, for example, could take this information and use it almost in an offline or analog form, and tell workers that if they see someone who comes into the bank who's married, who has over $100 of capital gains, is younger and is educated, that that's the one they should target for this new loan offer. However, there's more data and more information to be gained from this model. First of all, we have our model summary report. This model summary report shows you many things, including the field importance. And you can see here what are the most important fields in determining the predictive outcome. So, for example, we see the capital gains, and occupation, and capital loss are the three fields that have the most impact on the ultimate prediction. Most significantly, however, we've now trained a predictive model. And from here, we could do a number of things. First of all, the model is fully actionable. So I can download the actionable model in a number of languages. All right, so say, for example, I want to take it in Python. I could take this Python code and pop it up and copy and paste this into a local shell to run predictions locally. at the end of the day, the predictive model is just a nested if-then statement, and it can be reflected in a variety of languages. You can see we've also done Tableau extract, which allows you to bring this data into Tableau. If you're working in Tableau, and you can run this as a calculated field to run predictions in the Tableau environment. We've also done an Excel export. This is another example of how portable the model can be. You can actually download the model in Excel, as I'll show you here. And then in Excel, you can actually run the prediction as well. So here's someone, let's say someone is, we can type in their age, and you'll see on the right-hand side here, the prediction should change as we fill in more information, depending on what we want to enter in. You can see we have a prediction here. At this point, someone's going to be under 50K with 92% confidence. And however, if we change the capital gains, we now have a very different prediction. So this is a fully actionable model realized in Microsoft Excel, which is a very portable format naturally. You can also do multiple predictions here if you have a lot of data points you bring into this single Excel file and run the predictions as such. So let's go back to the model here. Something else we can do is run predictions inside the interface. So we can, similar to what we did in the Excel field, we can run predictions here. So I could type in the different variables and choose the information I may have or may not have, and then run a prediction as to whether or not someone's going to make more or less than $50,000. In this case, with these fields I typed in, we have good confidence they're going to make more than $50,000. So we've now trained a model, and we've now run predictions against that model. I want to show you how we can use this information to predict the future in a forward-looking way. So say we have a new data set. These are new customers that are walking into the bank, and we don't know their income quite yet. And again, we want to find people who make more than $50,000, where we have a very high degree of confidence that they're making more than $50,000. So let's go ahead and look at these 16,313 new individuals. This is a new data set. What I'm going to do here is simply bring this data set into BigML, this data source into BigML, and it'll soon appear in my source view. I'm going to do this quite quickly for the sake of time. I'm going to build a data set with a one-click cloud action button here. You can always circumvent some of the interim steps with this box. So I could have gone straight to model had I wished. And once I have my structured data set, you'll see this looks very similar to our other data set. The only thing missing, of course, is the income. So what we want to do is a batch prediction against all 16,000 plus rows of data. We simply go here to this batch prediction selection. And I'm going to search for the model that I built. So here's my model. And with a couple of clicks, I can choose the output settings for what will be reflected in my download. So I'm going to add a header. I'm going to include all the fields. I want to include a confidence. And then my prediction column name will be income. Okay, and then I'm going to click predict. And very quickly, we've now created a batch prediction which can be downloaded as a CSV. And here are the predictions. You can see now we have these two added fields with the income prediction and the confidence. In a very crude way, I could actually filter this now and choose only people who made more than $50,000 and with confidence of 75% or greater. And presto, we now have the 1,300 people out of 16,313 who we may wish to target with this special loan offer. So that shows you the end-to-end workflow for building a batch prediction with an unscored data set against historical data. What was not shown here was how to evaluate your models, build ensembles for even higher predictive value, and a variety of steps that are also included in the BigML environment, which can be shown in other demonstrations.